Today we will read or learn about center of gravity and uniform circular motion. This is the last part of the first chapter force. We will cover this portion today. It's quite easy, so let's start. First we will learn what is center of gravity. This is a very important topic. You know that the gravitational force between two masses is always attractive. That is, the gravitational force is always attractive. The earth attracts every particle towards its center by the force of gravity on the particle, which is called the weight, and we know that the weight is denoted by W. A body can be considered to be made up of large number of particles. That is, if the body is large, that means we can think that it is a sum of W1, W2, W3, W4, all that. As the size of the body is quite small in comparison to the size of the earth, the force of gravity W acting on this particle can be assumed to be parallel to each other, shown in this diagram. All these parallel forces acting in the same direction, that is towards the center of the earth. And the single force W can be written as W equal to W1 plus W2 W3. That means W is the summation of all the forces. Okay. Now the question arises, where should the weight W act? That means we have to find the position of the point G such that the algebraic sum of the moments due to W1, W2, these all parts will be 0. That means the point of G will be such a point where all the moments of the forces, that means W1, W2, will be 0, is known as the center of gravity, and that point is known as the center of gravity. So what is the definition here? The definition is, the center of gravity of a body is the point about which the algebraic sum of moments of weights of all the particles constituting the body is 0. It's clear. The entire weight of the body can be considered to act at this point, however the body is placed. Okay. So what I describe here is written here. So you can write and you can see it. It's quite easy. Okay. Now let's see the next slide. Now some important point we have to remember while we will read on the topic center of gravity. Now the position of center of gravity, lots of various shapes of objects are there. Some are triangular, some are rectangular, some are just a ring structure, all are there. So what will be the center of gravity for all this kind of object? Now the first point, the position of center of gravity of body given mass depends on its shape, that is on the distribution mass in it. It changes if the body is deformed. That means suppose this one is a rod, this is a straight rod is there. So where will be the center of gravity for this rod? This will come just the middle of the rod, the center of the rod, the center of gravity. Now if you bend this rod just like a ring structure, you use this same rod and just like a ring structure, now just see that the center of gravity, then it will change, it will come just the center of the circular ring. Okay, so the position of the center of gravity of the body given must depend on its shape. That means if the shape of the body changes, then the position of the center of gravity will also change. Okay. Now, it is not necessary that the center of gravity always be within the material. It's not necessary that the center of gravity always within the material. Sometimes it may be outside the shape. Okay, just in this ring, the ring is the material, but the center part is vacant, but the center of gravity lies just the vacant space, just inside the vacant space. Okay. Now, by the concept of center of gravity, a body weight W can be considered as a point particle of weight W at its center of gravity. Okay. For stable equilibrium of a body, its center of gravity must be as low as possible. Now, this one is very important concept. For the equilibrium of a body, the center of gravity must be very low and above the base and near to the geometric center. Now, near to that means there comes a point, that means center of gravity and geometrical center may not be the same point. Okay, so the equilibrium of a body, the condition is what? The center of gravity must be low as possible and it must be above the base and near the geometrical center of the body. Now I make a list of some regular shape of object and where the center of gravity lies or placed in that kind of object. Okay, if we consider a rod, straight rod, or maybe a straight where the center of gravity lies at the midpoint of the rod. If you can consider a circular disc, it will be the geometrical center and the center of gravity will be the same point. Now, in case of a solid and hollow cylinder, the midpoint on the axis of the cylinder, it will be the midpoint and the axis of the cylinder. In case of a solid cone, so in case of solid cone, there it's very different, very important, because the geometrical center, the center of gravity for solid cone and the hollow cone is different. Okay, so in case of solid cone, the geometrical center, the center of gravity is 1/4 of the height of the axis from the base. Now let's see the next slide. Now the hollow cone, in this case the center of gravity is the 1/3 of the height of the axis from the base. So in case of the solid, in case of solid it's 1/4 and in case of hollow it is 1/3. Circular ring is always the same geometrical center and the center of gravity is same. Triangular lamina, the point of intersection in all three medians is the center of gravity. In case of parallelogram, rectangular, lamina, square or rhombus, maybe the point of intersection is the crossing point of the diagonal. Okay, these all shapes are very important. Sometimes in question, in examination, this kind of question is very frequent, that some kind of shapes are given, the regular shapes are given, and you will be asked, so where will be the center of gravity in for that particular shape. Okay. Now the next topic is the uniform circular motion. It is very important and very interesting. That is, we already learned about uniform linear motion. Now this time this is uniform circular motion. So what is the definition of a uniform circular motion? Now when a particle moves with a constant speed in a circular path its motion is said to be uniform circular motion. Note these 2 points. It's constant speed. When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. Up to this point, it's right. Now, there comes some twist. That is, the speed is constant, but when a body is rotating or moving in a circular path, just see this, its direction is continuously changing. The direction of motion of that particular body in a particular point is continuously changing. That means its velocity is not constant. This is written here. The continuous change in the direction of motion implies that velocity of the particle is not uniform. That means the motion is accelerated motion. Okay. Direction. How you will find the direction? If you want to find the direction of a particle in this particular point, draw the tangent. Nothing else. Draw the tangent in the direction of movement. It will show you the direction in that particular point of that particular particle. Okay. So already I mentioned in the previous slide that there may comes a question. That question is, we know about the uniform linear motion, and we already learned about the uniform circular motion. So what is the difference between uniform circular motion and uniform linear motion? It's your task to think about it and write the answer. Okay. Now go to the next topic. That is centripetal force. It's not centripetal force, basically there is 2 types of force, centripetal, and we also learn about centrifugal force. So what is centripetal force? Just take an example first. Suppose this one is sun and this one is the earth. In this diagram it's showing that earth is bigger than sun, but okay, let's take it the earth and this is the sun. So earth is rotating in a fixed orbit around the sun. So if you consider this example, the planet moves around the sun in a circular path. So with the gravitational force of attraction on the planet by the sun is acting. Now see the definition. The centripetal force is the force acting on a body moving in a circular path. The centripetal force is the force acting on a body moving in a circular path in direction towards the center. That means in case of centripetal force, the direction will be always towards the center. Okay. This force is called the centripetal force. In this example, the sun and earth or sun or any kind of planet example, the gravitational force provides the centripetal force. In case of centrifugal force is such a force arising from a body's inertia which appears to act on a body moving in a circular path, is directed away from the center around which the body is moving. That means if the earth is moving in this direction, so gravitational force provides the centripetal force, and this force acts towards the center. But there is an opposite force due to the inertia of the body acting just the opposite direction of the centripetal force. This force is known as the centrifugal force. Okay, the direction of the centripetal force and the direction of the centrifugal force is just the opposite of the centripetal force. But you have to remember one thing, that centrifugal force is not the reaction force of the centripetal force, because in case of action reaction we know that the action force and reaction force does not act on the same body. But see here, the centrifugal force and the centripetal force are both are acting on the same body, so it's not kind of action reaction force. Maybe their magnitudes are same, but this not the same action reaction force. Okay, again comes a question. It's very important question, and if you say the top 5 important question from this total chapter, this is one of the important question. Frequently this question comes in the examination, schools and board examination, that is the difference between centripetal force and centrifugal force. It's quite easy, and I will not tell it. I will ask you all to read your book, and what I describe here, try to read it from your book and try to answer these questions. Okay, there are lots of examples of centripetal force and centrifugal force are there. Read each and every example. This all will help you to solve the various kind of conceptual questions given in the examinations. Okay, thank you.